Without further ado, let me introduce DJ Shalene with Yahoo Paranoids. And the topic for this morning's session is the end of DevSecOps. So welcome to DJ.
Hey everyone. This is really interesting here. I was mentioning earlier, it's like judges' tables. So, you can always hold up a card or something like that and say like 5 or 3.5 or something like that. Anyway, I'm DJ Shalene. As mentioned, I'm from Yahoo, part of the Paranoids. It's our security organization there. And my topic today is called the end of DevSecOps, ? And it's probably not the topic that you thought would start off the DevSecOps track at RSA, right? It's a little bit out there. But I think that DevSecOps, we've done a lot of it in the past. And there's an expansion that needs to happen. So it's not necessarily the end of DevSecOps, but there's a lot of changes that need to happen. So I'm going to start off with a little story about how I got involved with DevSecOps. I think it was around 2015 when I walked into my new job at one of the biggest healthcare companies in the world. And I had just gotten off a red team assessment. So I was hacking and breaking into buildings. And I think my tolerance for getting arrested was pretty small at that time because I had a young girl at home and 2 other kids, and my wife would have been really sort of angry if I ended up trying to post bail money. So at this organization, at this healthcare company, I ended up getting hired as a mobile application architect, which has absolutely nothing to do with security. And the first challenge that I had when I was there was to automate our CI/CD deployments for mobile apps, which doesn't sound anything like security's involved there. But we cobbled together a Stash server for our SCA, or for our software repository. And then we ended up using Jenkins to trigger off builds, connected it with a bunch of scripts and witchcraft over to Xcode Server, and it worked. We started deploying automatically to the App Store. But with a security mindset in my head, I was like, we could probably do better than this. We had some static analysis and security testing tools. We had software composition analysis tools, but they were run out of band. So we didn't have them integrated anywhere. And this was, again, about 2015. So we're trying to figure out how to get these security controls automated. And then we threw our SaaS tool in there, and there's no feedback loop. So it was just running, and we would end up getting the results back. But it worked. And we're like, wow. So now we had these continuous security scans as we started building software. And what that allowed us to do was start measuring how we reduced the amount of vulnerabilities by using a metric called defect density. So how many vulnerabilities in 10,000 lines of code? And that was sort of cool. So we ended up taking that technology and migrating it over to a lot of our other systems and our other repositories. So at this affiliate that we were at, we had 64 repositories, APIs, mobile apps. We extended it out. And then we got a bunch of beer, pizza, sat on a Friday night, and decided, hey, we're going to get rid of all of our security bugs. And it actually worked, and we were clean for like 1 day, because you're only as good as your last scan, right? And so that was fun. And then I thought, you know what, this is a story. We should probably start talking about this and sharing it. And I got contacted by Mark Miller, who puts on a show called DevOps Connect. And at RSA 2017, I started talking about DevSecOps. And that didn't really fly. So at the speaker dinner beforehand, it was a DevOps conference called DevOps Connect. I'm sitting here, it's RSA, so we're talking about security. But the speaker dinner beforehand, I met John Willis and Damon Edwards, just humble, and then Shannon Leitz, who coined the term DevSecOps. And it was really awesome. I realized that these are just like normal people. Like I was reading their books, and I'm like, oh man, these are like geniuses. And they're just normal people trying to figure out security issues and trying to automate pipelines. So the funniest thing about this, though, and I'll end off my background story with this, is that at the expo afterwards, I was watching a presentation, and this guy comes up to me and we're commenting and just talking about the content. And he says to me, what do you do for a living? And I said, I'm a DevSecOps evangelist and security architect. And he looked at me with this like crazy stare and he's like, DevSecOps isn't even a word. And I was like, okay, well, wait 5 years. And now it's 2017 when this happened. Now it's 2024, and we're here talking about DevSecOps, actually probably the end of DevSecOps. But again, I don't think it's the end. More so, we just got to think a little bit more about what we're doing. So 15 years of DevOps, which is crazy. And the security or the tooling for automation and pipeline deployments has really matured over the years. I remember that we were trying to get these continuous integration tools put together, and it was taking, there wasn't really things available. So we'd cobble together releases and we'd cobble together deployment systems. And then there's this maturity. DevSecOps comes, and all of a sudden we're like, there's no security tools, everything's slow. There's a bunch of toil that's introduced. We have a lot of things that we have to think about. There's no automation. So I'll give a brief history of all of this. Back in pre-2000s, there was a lot of frustration in the industry. We would develop software, we'd throw it over the fence to the testing organization. Our testing QA would say, hey, it doesn't work. They'd throw it back. Then we would try to figure out what was going wrong, throw it back over. Testing was fine. All of a sudden, we would throw it over to operations and be like, hey, this doesn't work in production. So does anybody remember that? Like, that was crazy times, right? And it was frustrating. So then in 2009, we have Patrick Dubois. He comes out in Ghent, Belgium, and creates in October this conference called DevOps Days. And all of a sudden, DevOps becomes a buzzword. And then 2010, Jez Humble writes this continuous delivery handbook talking about delivering value to customers and to end users. And that was one of the pivotal moments where we really started thinking, okay, we can start doing this, and we have this pattern, these practices in place. 2013, Gene Kim comes out with the Phoenix Project. Has anybody read the Phoenix Project? Let's raise our hands. Okay, if you haven't read the Phoenix Project, you probably should. This is one of the pivotal points in the life cycle or the lifespan of DevOps, where Gene Kim writes this book. It's very simple business speak English that goes into flow, feedback, and experimentation. So the 3 ways of DevOps. Then 2016-ish, Shannon Leitz writes the DevSecOps Manifesto, and we start really thinking about putting DevSecOps, our security controls, inside of DevOps. And now we have the AI craze. AI has become mainstream. Who's interested in AI here and what's going on? If you haven't raised your hand, you probably should. This is, I think, where we could start talking about, like, is DevSecOps going to end with all these AI, generative AI tools that are coming out? I think it's going to help. And so we're going to talk about that today. But I think when we started introducing security inside of DevOps, we not only used it 3 ways, we created 3 silos. And I think that we're still in this situation where security is this potential afterthought, there we go, to our processes. So today we're going to talk about a few things. The overall, or the overarching theme is going to be enriching data. And from an engineering approach, we want to make sure that our engineers have the information they need to remediate issues. Right? We can scan everything that we want, we can come up with all the vulnerabilities we want, but at the end of the day, it's about having the engineers remediate these things sooner and not getting bothered. We're going to talk a little bit about identifying opportunity areas to reduce manual effort. So we've done a really good job in the past of integrating static analysis, software composition analysis, watching paint dry using dynamic analysis, and container security analysis. So, but a lot of that is left. We've got to think about how we continue to move, right. We've got to continue to think how we move left. We're going to talk a little bit about solving security problems using engineering effort. So thinking like an engineer and coming up with solutions to enable them. We're going to talk a lot about SBOMs and what we can do with those, and assigning tickets automatically, which is pretty interesting. And we're going to explore a bunch of vulnerabilities and explaining those in a non-technical way. And then we're going to talk about making threat models a commodity, because threat modeling absolutely sucks. And everyone says you should do it. Nobody does, which is great. Or if they do, it's this massive spreadsheet. So on the engineering side, we want to continue solving problems with engineering effort. The first thing is, how do we integrate security in this seamless way? As an engineer myself, the last thing I want to do is say I have an IDE or some sort of interface, web portal, to go in and see my security vulnerabilities for SAST. And then I have a separate one I go into for software composition analysis and supply chain vulnerabilities. And then I have a separate one to do my container security analysis. Like, how do I get all of that together? So we need to figure out a way to consolidate all our vulnerabilities. Then how do we automate verification of these, the analysis and the vulnerabilities associated with it, and how do we centralize the inventory so we have one place to look for issues, one place to search for the inventory of the systems that we have? And then how do we disseminate the information to the right people? And this one's an interesting thing, because you can find all the vulnerabilities that you want when you're in a security group, but how do you have that disseminated to the right people? So vulnerability A that you have, you can send out a broadcast and say, you know what, fix this. But there might be 3 or 4 teams behind that issue. Who does it? And you're gonna have a wild goose chase. And again, you're not enabling your engineers by doing that. So continuing to push value to our customers. That's what DevSecOps is. That's what DevOps is. And our customers, we're forgetting sometimes they're the engineers who are actually doing things. So this is the system level view of activities in the SDLC. And I like separating this into 5 distinct categories. There's secure design and architecture. Then we have the things that happen in the developer environment with secure coding, CI process, the CD process and deployment. And then there's everything that happens afterwards, right? In the initial stages in the secure design, we look at architectures and threat modeling. When we look at the things that happen in the development environments, we can do static analysis. We can do software composition analysis. These are things and activities that happen on the developer's machine pre-check-in, pre-integration. And then we have what happens when we integrate. This is where we start looking at where we've been focusing over the last 7 years. Integrating security controls in CI, secret scanning. So I don't know about anyone here, but that's one of the worst things that a developer can do, is check in a secret. And now we have the ability to detect those, and even before it gets checked into a repository, you can find out and say, hey, this is an actual active secret that we can use, and then you can disable it. So these are the kind of things we want to do there. We want to do static analysis again. So we're looking at traceability and reachability for methods. We're looking at the things that developers create with static analysis. I did a study about, before I was back in healthcare, this was pre-COVID, called The State of the Software Supply Chain. And it was after I left this healthcare company, I had to get out of healthcare because it was just crazy. So I went and worked for a vendor, and we wrote this report, and what we found was 85% of all applications to 97% was open source. So things that we don't create in our own environments. And then there's 3%, potentially 15, but 3% for web applications usually, because of all the frameworks we use when we develop web apps. That is the things that we develop. So there is a big gap there. That's where we do software composition analysis. We can also do policy checking there too. So looking for specific tags, infrastructure as code, AWS, GCP. Are we labeling things with sensitivity and data classification? We can check that and make sure that as people check code in, that we're validating that they're adhering to the right practices. And then, of course, when we start building things and releasing things, we have to scan our containers. We've got to look what's in there. We have to scan our workloads. When we get out to the delivery, we have to do perimeter scanning and continuous bug bounty. We're looking for vulnerabilities on the exterior and the operational things that we do. So securing all of our nodes, looking and seeing that there's nothing nefarious happening to our clusters. But there's a ton of opportunity here. And the opportunities are getting rid of the M's. All the M's on this diagram are manual processes. Anything that's V is something that's generating vulnerabilities that we need to start collecting. So we can look at things like threat modeling. How do we automate that? Look at secure code review. Like, code reviews are pretty awesome. It's great to do. I hate Zoom calls and I hate looking at a bunch of code and analyzing it. We can do that in person if we were all in the office, but it's one of these exercises that don't need to necessarily happen. And sometimes they can get to the point where a developer is very defensive of their code. Developers and engineers are technical artists. They build code and they're very protective of it. And if you look at their code and say, hey, there's a vulnerability here, rather than saying there's a work item or there's a task that needs to be done, now all of a sudden you're separating things and you're getting to the point where it's like, I'm gonna fix the bugs, but not the vulnerabilities. So at the healthcare company, I got rid of all of the terms for vulnerability, bug, and it was task, because it didn't really matter what it was. Developer just had to work on it. So we have some opportunities there for secure code. Definitely some opportunities for managing the information flow out of our containers. And then there's a new swim lane at the top. And this is very important. We're going to get into this. But this is the inventory management. So software bill of materials. We can start off on the farthest side right and look at architectural decision records. So these are decisions that you would make across your entire security organization that says, here's one of our policies, and we're going to use this. Here, an example of that is the .zip and .move domains. Probably there's a .exe domain, like really stupid things that you can hack and send a URL, and all of a sudden you're executing something on your local machine. So one of the things we did was we brought that up in an architectural form, and then we came up with guidance that said, if we have these, what do we do? Do we block it, VPN block it? Anyway, that's sort of some of the things that we can do there with the inventory and the application, or the architectural decision records. And then there's inventory of what's on our client machines. What are your developers using? We also have the software bill of materials themselves. So what's in our software? That's the static or the software composition analysis, what libraries we use. And then image inventory as well. What's in our images? What's in our operating systems and our workloads that we deploy? And then, of course, we got product inventory. So what kind of tools do we use in our organization? So start off with intelligent team routing and how we disseminate information to our engineers to locate the location vulnerabilities. Why are we doing this? Stop ruining holidays and vacations. How many times have we experienced vulnerabilities in 0 days over Christmas? Like, I hate that. Like, we have Heartbleed. Heartbleed was over Christmas. And this was the first time that I realized that there's a supply chain issue. Because Heartbleed comes out, we're looking for a version of OpenSSH, or SSL. And the only way we could find out where it was by sending an Excel spreadsheet to all of our teams and all of our team leads and waiting for them to come back, which a lot of them didn't. And when they did come back, it was like, no, we're not using it. We're like, come on, of course you're using it. We just need to know where it is. So that was a nightmare to sift through that. And then we have log4shell. So we're searching for the log4j library. This is December of 2021. There's 4 patches that came out over the series of 3 weeks. And of course, the last patch comes out on December 28th, which is really great. Anybody remember that nightmare? if you don't, you're probably not putting your hand up because it's too early in the morning. So how do we figure out and sort of solve this problem? Well, centralizing inventory. So it's that whole top swim lane of that last slide that we took a look at. Looking for internal software and infrastructure. So this is not necessarily just, again, the supply chain and the things that come in or static or like the libraries that we bring in, but also the inventory that we have from an infrastructure perspective, things that are deployed. Vendor supplied software. So every piece of software that we buy goes through a procurement system, right? Or a third-party review process. Centralizing that is great for managing the business itself, but we can utilize that information and inventory it with software bill of materials. And there's some reasons for that we're going to get into. And of course, endpoint open source tooling. We talked a little bit about that in the last slide, which is finding out what developers have. So for example, Homebrew. You can install Homebrew on a developer machine. Developers can load anything on their kubectl. Gosh, you can deploy anything like Minikube, Kubernetes locally, Docker, you name it. The perimeter scanning tools, a lot of them just say Brew is installed. They don't say what the developer has installed from Homebrew. And that's a big gap that we have, that we can't see what developers have on their machine. All this is great for compliance requirements. So having that centralized inventory is going to be very important, not just for telling engineers where problems are, but for our compliance organizations as well. GRC, NIS2 is coming out. So we got until October 17th to attest that we have our inventory figured out for our, well, it's pretty nebulous what NIS2 is, but this is European regulation. And we're going to have this coming up fairly soon. Continuous scanning of primary and transitive dependencies. A lot of tooling that we have for software composition analysis, there's tools that are commercial that go through and say, okay, you have all these vulnerabilities and these transitive dependencies. Well, that's great. Tell a developer to fix a transitive dependency, and they're going to tell you how, because they can only address the primary dependency without breaking their code. You can't go in and just say, I'm going to take this library and change it out. So getting that primary dependency scanned is great, but the transitive ones, if we have that centralized inventory, we can still scan those. And then reduced time for supply chain attacks. So XZ, this is just last month in April. We got notice of this and we're like, where is this? So this is going back to that, do we send a spreadsheet out? It's like, heck no. We've been collecting at Yahoo 15 months of software bill of materials for all of our containers that we ship out to production. That's a lot of data. So definitely some retention policies. So we end up going through XZ. This vulnerability, if you're wondering what this is, a developer in 2021 creates an account on GitHub, does nothing until 2022. They make a small commit into the XZ repository. A year later, in 2023, they set the stage by doing another commit, and all of a sudden there's this back door that nobody notices. They've gained trust over the years, and they become a contributor to this repository. And then XZ is rolled into SSH, and now all of a sudden we have a backdoor in all of our SSH connections. So this is great. So this comes out, and we're like, oh my God, where is this? Is this in any of our workloads? So we did a quick scan through our database, and it was just a query that we did. There's no automation. 10 seconds, we found out exactly where it was. We knew every single place that it was, and thank God we didn't have the vulnerable version. But then taking it a step further, we have XZ that can be installed on a developer machine. So we had all of our inventory from Homebrew. And we realized that, yeah, we were using the vulnerable version, but on the actual piece of hardware itself, it wasn't affected because we were using a Mac in that case. But we could very easily say to our endpoint management team, just do a brew upgrade and it'll roll you back. And all this, basically, we look at it and it was painless. So we went home and didn't have to worry about it. Thank God it didn't happen over Christmas. It happened over April, 7th. So how do we do all this? We've been talking about inventory, we've been talking about collecting all this information. So I want to talk through this diagram here. And the central focal point is that database in the middle. So we have in the top right corner, developers creating code. That's the green part. So those are the manual things in this diagram. Building the container code, the images. Anything that's blue is as we start going down the CI/CD process and the build and check-in process. One of the things that we used to do when software bill of materials first came out, the inventory's been around for ages, right? SPDX been around for ages to talk about hardware inventory and circuit board inventory. We have CycloneDX that comes out as a format. It's really flexible. So we used to generate them on the client side before we check them in so that every single change set in our repository had a software bill of materials. That was way too much. We ended up spending a lot of time and effort dealing with that. And then, of course, all of the storage costs just went through the roof because software bill of materials are not small. And then going through the GitHub actions there, we start building and deploying. We generate a software bill of materials for application. Send that to that central repository. For the containers, after we build it, we use an open source product called Sift. And then there's Gripe. Sift generates software bill of materials, converts software bill of materials. Very handy tool, open source. So we create an SBOM for that. And that's all of our container inventory, so the operating systems that come underneath. Send that to our centralized database. And then we have Gripe. Gripe does the security scanning of those images. So this is coming out with, you have this library. This has a vulnerability. Another open source tool, which is pretty cool. So at this point here, we pretty much have software composition analysis for our containers, all open source. We take that, we can use what's called a VDR, Vulnerability Disclosure Report, or even a VEX document. Store that in our centralized database. And then there's 3 other points here where we can bring in software bill of materials. And all of this ties together. So these are our third-party vendor software. Think about this as anything that touches your code, right? You're doing a software bill of materials for your code that's going through. You're doing it for the environment and the workload that you're deploying. But you're also looking at every single tool that's touching your code. SolarWinds, right? There's a vulnerability right there. So Jenkins touches your code. Software bill of materials, what's in it? GitHub, I don't know if they're going to give you a software bill of materials, but you can ask for it. And ultimately, with all the compliance and the regulations that are coming out, and the supply chain attacks, there's going to be government regulations. And again, the EU is leading the charge in this. But get our software bill of materials in our third-party governance programs, where we're doing our software reviews, get the SBOMs from the vendors. And depending on the size of your company, you could leverage some muscle and say, you know what, we're not going to buy that from you if you don't give that to us. And not only do we want it when we buy the software, we want it with every minor release. We also want it in our contractual arrangement that says, hey, you have to provide this to us, and on a regular basis too. So if they don't do updates, at least we still have software bill of materials coming in. Endpoint inventory, what's on our developers' machines? Not just developers, but like anybody in the organization. What are they installing? What are they using? And then this one at the bottom, LLM inventory. So CycloneDX, it's my favorite schema and format. there's a long history. If you want to get me after, I'll tell you about Cyclone DX and SBOMs. But that inventory there, it's an ML bomb. So this is tracking the LLM, the provenance of where it came from. So provenance, sorry, my mic cut out, of where it came from. All the things that have been done to tune it, and even the training that goes behind it. So there's going to be a lot of focus on that. And this hasn't really hit right now, but with all the craze around AI, this is going to happen. So bringing that inventory into our centralized repository. And then what can we do with this? Imagine a CVE coming in through a feed. It's a 0 day. And we're like, what? Where is this? We can query the vulnerabilities that we're detecting in that centralized SBOM library, get them, know where they are, and attach them to a JIRA ticket or a work item right away. So imagine coming into work and being like, oh my God, there's a 0 day, I gotta find out where this is. And in 10 seconds you already have this artifact that you're looking at that's saying, this is where the vulnerabilities are. And then there's this thing called Bomber there. And I'm gonna get into this on the next slide. So Bomber is an application that I wrote one summer. I had the summer off, it was 2 years ago. And I had a manager that was reporting to me, and he's like, this SBOM program that you implemented, well, this is great because now I'm getting these crazy things like requirement.txt files, go.mod files, all these different kind of formats instead of software bill of materials in a standardized format. I have to go through these things manually and figure out if there's any vulnerabilities. So I had left the company. I'm like, oh man, I left you guys with a big pile of trash. So I wrote Bomber, and it does scanning of software bill of materials and looks for vulnerabilities through open source vulnerability feeds like OSV. It also integrates with OSS Index from Sonatype. And think of it as GRIPE, but for apps. So GRIPE does a really good job of scanning RPMs and DEBs and infrastructure-related ecosystems. Bomber will scan your application ecosystems. So Go, CMake, NPM, PyPy. And this again scans SBOMs for vulnerabilities. So in that previous diagram, what we were doing there was scanning continuously the SBOMs that are in that registry. And that's giving us a transitive dependency scanning. It's also giving us that centralized inventory of vulnerabilities. And you can automate this as well. So this is a domain diagram. And this is how we can figure out which team fixes image vulnerabilities. And I'll walk through this. Again, the slides are going to be available afterwards. But the idea behind this is we detect a vulnerability in a container during the build. We can, sorry, I'm going to have to look at this because this one's crazy. We can generate that SBOM, and then we can take the SBOM, scan it through GRIPE, and then what happens is the software bill of materials has all the components in it. GRIPE has all the vulnerabilities, and the nice thing about it is there's this correlation between the image ID and the layer ID. So we can find out, based on that, where in that image the vulnerability lies. And why is that important? Because again, you might have 3 teams that are involved in creating this. You have the application team that's creating the application. That's going to be thrown on a layer. You're going to have your base operating system, your golden images. Those might be created by a team. And you might have some intermediary layers in there as well. So knowing where the vulnerabilities are, and when we build our software, we have a ton of metadata that we attach to our images. So we know that team A has this repository, hey, they have this vulnerability, and then we can automate the delivery immediately to the developer. So that's targeting your engineers with the information they need to fix the vulnerability very quickly. See a picture being taken, so before I go to the next slide, I'll let you do that. If you haven't seen domain diagrams, domainstorytelling.org. Great. It's a good way to explain in business speak what a process is. So decoding a CVE. This one is, doesn't have anything to do with SBOMs. I don't know how that got in there. But it's exploring and explaining vulnerabilities and the information in there in non-technical speak, because not everybody understands tech speak. Even if you do understand tech speak, getting something like this, like a deserialization of untrusted data, vulnerability exists in Rails, et cetera, blah, blah, blah. Okay. And, like, what is that? Like, what does that even mean? You know, why do I need to think about this? Is this important? How do I prioritize this? You know, you might have a CVSS score that's associated with this vulnerability. CVSS scores, I don't know, they don't really tell us much. They don't tell us how to prioritize the work. They tell us that, you know, it's a 10, but it doesn't tell us that we have these compensating controls that really make that a 7.5. Which one do we fix first? Prioritizing the work. There's a project that Chris Madden's been working on. He works with me at Yahoo. And he wrote up this paper about risk-based prioritization. It combines EPSS scores with a decision tree and calculations, where not only can we say, you know, the CVSS score is this, we have to translate that into priorities that we want from a security organization to fix. But again, you get 2 P1s, priority ones. This one is 98% probable that it's going to be exploited. This one's 75. So which one do I do first? The 99, right? The highest risk. And if you give this to somebody who's analyzing the vulnerability, like let's say it's your vulnerability organization, you have like a security analyst that has to triage this. What is Rails? Like, imagine if you had Delphi, and someone's like, is that like an oracle sitting in Rome somewhere? Like, you have to explain this. So, this makes a bit more sense. So with Bomber, that same manager came up to me a couple months ago and said, I gotta justify budget now to remediate these vulnerabilities. And that's sort of weird, right? Like, how do you justify budget? Like, it's a vulnerability, you gotta fix it. But, so what I did was Bomber, I integrated AI. And the prompt behind this, it's available in open source, and there's a link at the end of the presentation you can check out. And if you wanna help me with it, it's great. But the prompt behind this was explain that last CVE in non-technical speak. Like, it wasn't like this crazy prompt. It was just this simple thing. And it came back with this. So we're actually taking this and the ideas and the technology, and we're implementing that today so that we can give this to our junior analysts, and they already have the information that they need to assign these tickets to our developers. And having the developers see this, and the product owners, now they know what this actually can do, right? So enriching work items with generative AI, another domain story. So you end up, we talked a bit about this, you end up having a vulnerability come in, CVE potentially. It could be anything. You can take any kind of explanation, throw it at an LLM and get some information back. We'll talk about hallucinations in a bit. You know, we create a prompt, send it to an LLM, generate an explanation, and return this back to the system. So in Bomber, I had a schema that basically, it's an internal schema based on the Sonatype vulnerability schema. And I added an explanation. So now it comes out in JSON, comes out in an HTML report. So you can generate an HTML report from your software bill of materials and get an explanation about what you need to do. Sorry, I keep turning my head, so if you miss something, just throw something at me. And this is my favorite point. 10 minutes left? Oh man, I talk way too much.
I did that earlier, and I'm sorry.
You got to do that like you're in a wrestling ring, right? It's like round 10. I talk a lot, so I think the first time I did a run through of this presentation, it was 75 minutes. So that's probably not going to work. You probably have other talks that you want to see. So making threat models a commodity. Who here threat models? Whoa. I'm going to pick on someone. How do you do it?
Actually, for some projects, people come to us with threat model for each project.
Is it like a document, spreadsheet?
Yeah, actually, we have a ticketing system. Come from there.
Okay, cool. So a ticketing system, threat models come in. And that's pretty cool because we're going to talk a little bit about this too, and we're going to use generative AI to make this happen. So once again, threat models, tedious manual effort, they absolutely suck to do. And then trying to find a tool that does this, there's a bunch of wizards out there. There's tools that you can click through. And really, it doesn't give you a threat model, it gives you requirements. Done in spreadsheets usually. And it relies on what the people who are modeling know about the potential attack vectors of the scenario that you're looking at. And then it's rarely done in a standard format. So we have MITRE ATT&CK framework, right? We can get threat models out of there, or even STRIDE. So spoofing, tampering, repudiation, information disclosure, that whole idea where it comes back and you get that information, remediation steps, mitigations. But all of this should be considered as enrichment. So this is an application called STRIDE GPT. And last year, Sean Porras in the audience, put me on a Tiger team at Yahoo. And what we wanted to do was learn as much about generative AI as we could. Because again, the business is going ahead, and we're like, whoa, what's this AI stuff? So I was participating in a lot of conferences and listening to a lot of talks, doing a lot of research, and I came upon STRIDE GPT. There's a link at the end of the presentation. I'd go take a look at it. And this is an open source version of what we're doing right now. But on the right-hand side here, here's the prompt, and it's a big one. And the interface is just this Python interface. And what I did was I ran a threat model on STRIDE GPT here. So STRIDE GPT allows you in this Python interface to put in a description of what the product is. Is there authentication? Is it internet facing? Is it cloud technologies, et cetera? And it puts it through this prompt, and it generated everything on the left-hand side, which is really cool. So we have the threat model itself, talking about what the problem is and what the impact is. But my favorite part is improvement suggestions, because you can ask it to tell me what I'm missing in my threat model. And that's pretty cool. So what can happen with this is if you have a problem or a security request come in or architecture request, that ticket can come in, and within 10 seconds, you have a touch on that ticket from your security org, passes it back to the person who submitted the ticket and says, hey, you can make this better by doing this. And that's pretty cool. And then you have all of the mitigations that are suggested there. So here's how we can enrich the security review request with AI. So again, a ticket comes in, it's a security request, and it says, hey, I want to do XYZ. Immediately, we create a prompt, pass that payload from the issue to a processing system. It will take that, generate a prompt, send it to the LLM, asking for the information back, and then it'll create that comment, reassign it back to the user, but it'll also put the full threat model in a field inside of the ticket. Now, the cool thing about that is every time you change the ticket, you can do another threat model. So as you start getting more information, you have the threat model right there. So now you don't have to touch it. You don't have to think about generating it. You don't have to buy a tool to do it. It just happens. But we can do more than that too. So we can use generative AI enrichment on a bunch of different tickets. So imagine you have a security request coming in and it spins off something for privacy to check out. One of the interesting things, we were evaluating a product and it was just an extension on a product that was already approved. And so I was trying to figure out, why is it taking so long to do this privacy review? So I reached out, and the privacy person said to me, I don't even know what the heck this is. So I have to create all these meetings to find out what the system does, where does the data go, what's the classification. Well, we could use it for that, and we could break down all the information in a language that they understand. Analyzing problems and providing breakdowns. So imagine sending an architectural document into a ticket, taking those diagrams, passing it to generative AI and say, give me a problem breakdown. Am I missing anything in my architectures? Again, doing this automatically. Looking at architecture from the developer and the engineer and automatically saying, here are the security issues or security constraints or the mitigations that you need to have around this architecture. We could even do some crazy stuff legally, where we could take all of our information, have a LLM that's tuned or trained on legal precedents and documentation, tuned with our information internally, and then potentially redline contracts. But, what about hallucinations, right? I can tell you right now, I'm going to go to this SBOM party tonight. It's the 3rd annual SBOM meetup. If you can, check it out, because it's pretty cool. And then probably after a couple of beers, I'll be hallucinating because people make mistakes too. Just having AI generate something to take a look at doesn't mean that you're absolved from checking it out and making sure that it's accurate. So putting some disclaimers in there. And I think that's going to change over the years. We're going to have a little bit more trust as the technology starts evolving. But again, looking for vulnerabilities to enrich your data, that's going to be pivotal. So applying what you've learned today. In the next week, catch up on email next week, but in the next week, check out a lot of the great talks that are coming up on the DevSecOps track, as well as other tracks about generative AI. There's going to be talks about software bill of materials. Those are the hot topics now. If you're not collecting SBOMs, ask yourself why, and start looking at a program to start creating them. Now is the perfect opportunity to do that, especially if you're selling to the government. You should already be doing that, because you can't sell a product to the government now without a software bill of materials. Think about how AI can help you communicate to your engineers and translate any language barriers. In the first 3 months following this presentation, build that systems level view of your SDLC and identify where you're collecting vulnerabilities, where you're doing automated work, and then detail where the manual is. And then start breaking down the manual and thinking how you can automate that toil away. And then make things effortless as well. We have a lot of better things to do than document or research. Utilize the tools of today to take care of that, and then we can start focusing on other value deliveries, not only to our customers, but to our engineers. And in the next 6 months, I'm going to be digging into this a lot. Security reviews on code. Commoditize that. And you should probably do that as well. So wrapping it up today, can't believe we're almost at the end of the presentation. I'll leave some time. I got 1 minute. 2 minutes left. That's crazy. Man, now I can enjoy the rest of the conference. DevSecOps is evolving. This is not the end of DevSecOps, but it's going to change. So even those tools that we're using for software composition analysis, static analysis, those are going to evolve. And if you walk the expo floor, I bet you there's going to be someone talking about it. Hopefully they're not talking about zero trust, because we know about that from last year. Enhancing the feedback loops. Get the information again quickly back to the developers with as little effort as you can. If you're in a security group, they're your customer. Getting that information to them rapidly is going to help your relationship with them. It's going to start breaking down that DevSecOps silo. And it's going to go back to DevOps, because really at the end of the day, we're all engineers. Continue innovating, and what are you going to do in the next 5 years, right? Going back to that story about saying wait 5 years and see where DevSecOps goes. I wonder what it's going to be like in 5 years. I think it's going to be a lot different than what we see now. So if you find yourself with a DevSecOps team and a DevOps team, you haven't done anything wrong. It's just sort of what's happened and how it evolved over the year, but you have opportunity to simplify. So some resources to help. Again, this presentation will be available online. CISA.gov, SBOM, a lot of good information there. Check out cyclonedx.org. It's a great format for inventory. Not only can you do ML bombs, you can do software materials for applications, I bombs, H bombs, atomic bombs, you name it. You can do a whole bunch of it. And then some of the open source tools I discussed today, we got Bomber, DevOps Kung Fu Mafia, /Bomber, Stride GPT, Mr. W. Adams, Stride GPT. Take a look at that. You can actually download it and look at it, but the prompt is specifically tuned for that. When we're doing it, we're going to sort of make it enterprise strength. And Sift and Gripe. So Sift, I got Gripe wrong. Basically, it's Anchor/Gripe and Anchor/Sift. So all on github.com. With that, thank you. I think we got 8 minutes.
Actually, we are like out of time.
Oh, we're out of time.
Yeah, out of time. But would DJ, would you be open to answer any questions in the hall?
Yeah, I'll be over here at the end of the room or even outside.
Yeah, we have about 5 minutes. He can take some questions here. Otherwise, it has to be out in the hallway. But thanks again, DJ Shaleen,
Yeah,
with
thank you for
Yahoo Paranoids. Thank you.